And welcome back, students. We are now fully delving into some big O notation stuff. So let's actually look at some big O analysis. I kind of hinted at us going this direction. Now we're actually going to do some. So a function in big O notation can be written as f of n is equal to big O g of n. So we're going to take a function and translate it over into a form that is in big O notation. So for all numbers, there exists a big N that is greater than 0, such that the constant is greater than 0. And this inequality will hold such that when our little n is greater than or equal to our big N. So what this means is that our function is less than or equal to the constant multiplied by g of n. Right? So we have to find that upper bound. So what we'll end up seeing is our functions, pretty much this means you're going to take that function and kind of reduce it down to the parent function and multiply that by some constant. So like if our parent function, for example, was just, let's say, x, y equals x, then the constant, let's say, was 5, you'd have like y equals 5x, or in this case, f of n equals 5x. An algorithm will typically show this pattern as long as n is greater than or equal to capital N. So let's actually look at this. We're going to prove, in this case, f of n is equal to 5n plus 100. So we're not going to get too much into big O notation. We're also going to deal with a linear, and we're going to deal with a very simple polynomial, and then we'll go in. That'll be it. We're not going to, like I said, we're not going to get too much into big O notation. We're not going to do anything with logs. We're not going to do any of that stuff. It's just a kind of an intro lesson here as we go through this stuff, and then we'll switch over to talk a little bit about optimization. So let's do analysis of this function. First thing we want to do is find c times capital N. Then we test to see if n is greater than or equal to n. And then we write the function as f of n is less than or equal to capital C times n. So let's start with our function, f of n equals 5n plus 100. So let's rewrite into 5n plus 100 is less than or equal to c times n. I can also rewrite that as 5 parentheses n plus 20 is less than or equal to c times n. Just another way of writing that. What we want to do, though, is find that c and that n. Remember, those are the two things we're trying to find here. So if we go back to the 5n plus 100 is less than or equal to c times n, we can rewrite that technically as 5 plus 100 over n, parentheses, n is less than c times n. So what I did is I simply took that n there and pulled that out of the function. So I pulled it out and left it out there. And of course, because 100 didn't have an n next to it, it's now divided by it. Therefore, when n is greater than 100, that I know that 100 over n has to be less than or equal to 1. Because if it is 100, well, that's 1. If it's 101, it's now greater than 1. Right, we want it so that it stays less than or equal to 1. We substitute the 100 into n to get 5 plus 100 over n times, parentheses, n is less than or equal to 5 plus 1. Right? And how did I get that 5 plus 1, you might wonder? Well, if we plug in 100 here, this would be 100 over 100, which is 1. Right? So now I know that this is 5 plus 1, so that's what replaces this side of the equation. So this side doesn't change, but when I plug that 100 in, that's how I got the 5 plus 1. Therefore, I then can simplify this. I keep this left side still, 5 plus 100 over n, parentheses n, less than or equal to 6. All I did was simplify that side. We can then conclude that when n is greater than or equal to 100, that 5n plus n is equal to 6n. Our capital N was 100 and our C was 6. Now, let's just conclude this in a way that might be easier. Like, okay, we did all that math, all that work. What does that actually mean? Right? What we have just done is prove the function. So therefore, we should be able to map that algorithm to a big O notation. We know that f of n is equal to 5n plus 100, and that's equal to big O of 6n. Because you have to remember, you have to include the constant in there. So remember, there's always f of n is equal to big O of g of n. So that g of n in this case was 6n. And that concludes our notes, folks. Until next time.